Let's find the regression equation. Using the listed actor and actress ages in various years, find the best predicted age of the Best Actor winner given that the age of the Best Actress winner that year is 60 years. Is the result within 5 years of the actual Best Actor winner, whose age was 44 years? So we have these two sets of data right here for the Best Actress and Best Actor of each individual year. You can imagine that each pair of ages here came from a particular year where the Best Actor and Best Actress and Best Actor both won in that year. So first let's go ahead and open up this data in StatCrunch. We're going to do that by clicking on the little blue icon in the corner and selecting Open in StatCrunch. Thankfully, the data has come in here in columns, which is the right way we want to use it in StatCrunch to calculate these values. So we don't need to do any additional work to change this data. It's already in the correct format. So to find the regression equation, which is what we're looking for here in the first part of the question, we're going to go to Stat, Regression, Simple Linear. And we were told that the X variable is the Best Actress and the Y variable is the Best Actor. In other words, we're trying to use the age of the actress to predict the age of the actor. Everything else we can leave exactly the same, and we can go down and click Compute. So the values that we're looking for the regression equation are right here. Imagine again, Best Actor is like the Y and Best Actress is like the X. So the numbers here are the values that go here in the first cell not connected to the X, and the value here is the value that goes here in the cell connected to the X. So we can just go ahead and directly copy and paste. So I'm going to copy this first value that is not next to the X and paste it here. And then I'm going to go and copy this value. Notice that I'm copying the negative sign that looks like a subtraction. So that is important. If there's a subtraction here, you need to make sure that the value over here is negative. If this were a plus, then the value over here would be positive without that negative sign. And we'll remove that space. Then it says to round to 1 decimal place for the y-intercept. The y-intercept is the first value here that is not next to the x. It's just by itself. So that one we wanted to just 1 decimal place. Rounding correctly, that would be 52.1. And then it says to round the slope to 3 decimal places. So this one is the slope, the one that's connected to the x. So we want to round that to 3 decimal places. So that would mean we'd go 0.187. The number that comes after the 7 is a 9, which means we should round the 7 up to an 8. So we'll change that to an 8. And that should be our regression equation. The next question says, the best predicted age of the Best Actor winner given that the age of the Best Actress winner that year is 60 years is blank years old. So we're given the fact that the Best Actress is going to be 60 years old. And based on that, we want to find the best predicted age for the Best Actor. So there's 2 ways that this could go. And it all depends on how good of a line this was to begin with. If this line is quote unquote good, it means that it is a good formula to use to find predicted values. But if it's bad, then that means we don't want to use it, and instead the way we'll determine the best predicted age of the Best Actor is just by finding the average or the mean of the Best Actor values from the original data set. Well, how do we know if this line is good or not? It all goes back to the correlation. So if we look at StatCrunch, there's 2 ways we can decide whether or not we had good correlation here between the Best Actor age and the Best Actress age. The first way is by looking at the correlation coefficient. This is the R value. Here, the R value was negative 0.3. Remember, Correlation is good the closer the R value is to either -1 or +1. If you get an R value that's very close to -1 or very close to +1, then your two sets of data were very well correlated. But if the R value is closer to 0, that means you did not have very good correlation. So here, a value of -0.03, that's definitely closer to 0 than it is to -1 or +1. So that's indicating that maybe we did not have good correlation here. What's the other way? The other way is we can look at the p-value right here under the p-value column for the slope row. If the p-value is a very small number, maybe less than the 0.05 significance level that we often talk about, then that means that there would be good correlation. But a high p-value means that there probably wasn't very good correlation. So this p-value of 0.32, that's a pretty high p-value. It's certainly higher than 0.05, which is sort of our benchmark significance level that we use quite often. So this value also is telling us that there is probably not good correlation between the ages of the best actress and the best actor. And if there's not good correlation, then we really don't want to use this equation to find our predicted values. So instead, what we're going to do to find the best predicted age of the best actor, since we can't use the line, is we're just going to find the mean of the best actor ages and use that mean, that average, as our best predictor. Remembering all the way back to earlier in the course, we know how to calculate a mean in StatCrunch. That's going to Stat, Summary Stats, Columns, and then we're going to select the best actors and choose the mean. Compute. So the mean age of the actors is 44.75. So if we come back over here, we could round that to 45, as it says round to the nearest whole number as needed. Is the result within 5 years of the best actor winner whose age was 44 years? So was the actual age of the best actor winner, which was 44 years, within 5 years of the prediction we got, which was 45? Well, the answer is yes. 45 is within 5 years of 44. Those are only 1 year apart. So here we would say yes, the predicted age is 5 years or less from the actual winner's age. Now this was an example where the correlation we had was not very good, and that's why we used the average of the actors' ages to get that best predicted value. But what if the correlation had been good? What if the R value that we had from our StatCrunch was indeed very close to 1, or what if it was indeed, just going to bring it up again so we can look at it one more time. What if this R value here was actually very close to -1 or 1, and what if this p-value was very small, less than 0.05 or less than 0.01? Then we would have had good correlation. What would we have done in that case? In that case, what we would have done is taken the age of the best actress that they gave us, which was 60, and we would have plugged it into X in this equation of the line. The good correlation would have told us that this line is good. So just on our regular calculator, whatever calculator you have, we would have gone and taken this line, 52.1 plus negative 0.188 times, and then we would have put in the age of the actress that they gave us, which was 60. So the best predicted age, if the line had been good, would have been 40 years old, or 41 years old if we round. Again, that is only if the correlation was good, and hence the equation of the line that we got was good.